Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinite Land. This is Suresh, Faculty of Chemistry. How are you all doing? Meena Kumar, hello, good afternoon, and welcome to the session with ionic equilibrium in one shot. So we are going to discuss about the things which are there in one shot. So far we completed general organic chemistry and hydrocarbons and thermodynamics, chemical equilibrium. Now we are in ionic equilibrium. Are you ready for that? So in this ionic equilibrium, we are going to discuss so many calculation methodologies. In this scenario, what are the things to be done? We are going to see acid-base theories, we are going to see ionic product constant of water, we are going to see salt hydrolysis, buffer capacity and solubility equilibria. At last, we are going to see the titration and titration curves and the theories of indicators and everything, and stay tuned to us, and please like the session and share with your friends and subscribe to Infinity Learn NEET YouTube channel, and that is the worth of the day. Crack your NEET. Attend our class, take a pen and paper. I am going to give you a very good methodologies to solve the pH calculations, the strategies in pH calculations and everything. And in the Infinity Learn app, you can download it from Google App Store. There you can access live classes, mock test, create your own test, 24/7 doubt resolution sessions. And the students I really appreciate who are attending my classes on the YouTube platform on a regular basis. You just maintain the regularity and you are going to see the seamless preparation for your NEET examination. Yes, definitely I can assure you that when you are preparing for some examination, it is required to know where exactly you stand and what you do and what is your improvement areas. For that, NEET test series is there, All India test series. For that, it is your benchmarking yourself against India's best coaching institutes, where you can see 34 full syllabus mock test, in that 14 grand test and 20 mock test PM. And it is the every test you have a detailed video solution for each question as well. And you can see the cost, it was around 6,000 rupees. And it is on special discount. You are going to see for just 1,200 rupees. It's a price drop when you apply YT80 coupon code. In the description box, link is available. Everybody click that link and enjoy this test series. So promotion is over, my dear students. Let us see our ionic equilibrium. In that ionic equilibrium, and we are going to see everything about the equilibrium principles exist among the ions and the solutions. So right from scratch level I am going to discuss. Everybody follow us. I don't want to give you a lengthy slides. I want to give a crystal clear, crisp slides. So let's talk about the types of substances. Substances can be dissolved into the following, like non-electrolytes and electrolytes. The substances which are soluble in the water are two types: electrolytes and non-electrolytes. Let's see what are electrolytes and non-electrolytes. So here it is all about the electrolyte and non-electrolyte. Non-electrolytes, they are soluble in water. They do not conduct electricity in the molten state or in the aqueous state. For example, you can take a sugar, चीनी, आप पानी में डालना, ये dissolve करने के बाद sugar solution is sweet and it is soluble and do not conduct electricity. It's a non-electrolyte. You can say urea is an example, glucose is an example, glycerin is an example. So whenever non-electrolyte is there, do not ionize, rather they can simply dissolve in it. Let's talk about electrolytes. So electrolytes, they are soluble in water. When you put electrodes and pass electricity, it is going to conduct electricity. How it is going to conduct electricity? Because it is going to ionize. Say sodium chloride is going to ionize to give rise sodium plus and Cl minus. So their ions are responsible for this ionization process, and because of the migration of the ions from here to there to here, they are going to conduct electricity. So we don't discuss here, we are going to discuss here. And you have the electrolytes. These electrolytes again is of two types. Let's discuss about The concept ladder. In the solid state, electrolytes are bad conductors of electricity. They become good conductors either in the molten state or in the solution. So I want to say sodium chloride is in the solid state, it's a bad conductor. When you say sodium chloride in the liquid state, when you see in the molten state, it's a good conductor. When you say sodium chloride in aqueous state, it is going to be excellent conductor. They are going to be excellent conductor, right? So this is the behavior of these ionic substances. And you can see electrolytes, they conduct electricity. Yes, of course, when they are dissolved in the water. And these electrolytes again is of two types, dear. One is a strong electrolyte and another one is a weak electrolyte. A strong electrolyte hota hai kya? A strong electrolyte, they get strongly ionized, mean to say completely ionized, and they provide all the ions, and it is going to conduct electricity. Completely ionizes. Completely ionizes. And weak electrolyte, the conduction takes place but less strongly ionizes. I mean to say feebly ionizes, you can say weakly ionizes, and do not ionize completely, and they ionize completely. हमको कैसे पता चलेगा जो भी स्ट्रॉन्ग इलेक्ट्रोलाइट है ये वीक इलेक्ट्रोलाइट है? जैसे आपको स्ट्रॉन्ग एसिड्स and all strong bases and also all salts, the salt is the product of an acid and a base, are strong electrolytes. So all salts होते हैं नहीं, a salt of weak acid and a weak base is a weak electrolyte. Now we'll talk about weak electrolyte except these strong acids and strong bases. You have weak acids and weak bases, and a salt between a weak acid and weak base is going to be a weak electrolyte. So how do I know it is a strong acid or strong base? उसमें और एक चीज है. So there lies actual thing. Here you can see any alkali metal hydroxide is a strong strong base. HCl, HBr, Hi and H2SO4, HNO3, these are all strong acids, HClO4. But you can see anything phosphorus acid, organic acids, okay, these are all the weak acids. Acetic acid, organic acid, carbonic acid. So these are all the weak acids. And amines and ammonium hydroxides are the weak bases. Are you getting or not? Sorry. Apologies. Okay, let's see. We are going to see equilibrium here. They are going to see no equilibrium here. You can say, dear children, yeah, we're going to see here, dear children, when HCl is taken, it is going to give rise Hu plus and Cl minus. It is this process, you can see, it is a unidirectional and it is irreversible. When you talk about this, okay, HCnCH3 COOH, CH3 COOH, there is an equilibrium exists between these two, CH3 COO minus and H plus, and the reaction is reversible. The reaction is reversible. Are you getting or not? Clear? Harsh Kumar, हर्ष कुमार, आप क्या बोलना चाहता हो? आपको समझ में आ रहा है क्या? सब देखते हैं ना? Right. So let us follow here. We are going to see the equilibrium. We can apply equilibrium principle. यहाँ पर equilibrium principle JKC you have that now. You can apply here. You can see ammonium hydroxide is going to like this NH4OH is going to give you NH4 plus and OH minus over here, right? Doraemon, yes, I am explaining you this, and weak electrolyte do not ionize completely, and whereas a strong electrolyte completely ionize. Okay, मान के चलो पहले HCl है ना, 100 HCl molecules you take, when you dissolve in the water, you're going to get 100 molecules are getting behaving like this. That is the behavior of a strong electrolyte. While you can see a weak electrolyte, if you dissolve 100 acetic acid molecules, you are going to see maybe 1 or 2 molecule is going to behave like that. Rest of the 98 molecules will be there unionized. That is the behavior of the weak electrolyte. Do you understand? Equilibrium state, the state at which the reaction आगे बढ़ते हैं फिर भी वापस आना है. So state at which the both forward reaction and backward reaction takes place at equal rates, that state is called state of equilibrium. Okay, got it. Doraemon, hope you understand, right? Now let us talk about Arrhenius theory. Okay, Arrhenius theory we can apply here. We can apply Arrhenius theory here, right? So what Arrhenius theory wanted to say? It is also called as a dissociation of electrolyte theory or introduction of ionic theory. जब ये इलेक्ट्रोलाइट आयनाइज करते हैं ना, इसका हिसाब से आयन्स आता है. सो यहाँ पर इक्विलिब्रियम प्रिंसिपल्स इस्तेमाल करना शुरू किया. दैट इज व्हाट इज कॉल्ड Arrhenius theory. So this main postulates electrolytes on dissolving in solvent, they are going to split into their respective ions. So अगर मान के चलो AB is an electrolyte is giving you A plus is an ion and a B plus ions. This process is called ionization. There will be always an equilibrium between ionized state and unionized state. And you can see here ionization process is a reversible process. And आगे बढ़ते हैं ना पीछे भी आ सकते हैं. Are you getting or not? And the ionization constant is given as, so let us apply equilibrium constant. So equilibrium principle, that is K is equal to A plus and B minus, and it is going to be AB. Okay, this is what is said. It could be with an acid or it could be with a base. That I want to show you here. Okay, a concept of electrolyte here is a strong electrolyte. If initially a strong electrolyte is taken, initially C moles per liter is taken and 0, 0, and it is, once it is ionized, you are going to get C moles of A plus and B minus. While a weak electrolyte, C moles are taken and 0, 0, let us say alpha is the degree of ionization, C minus C alpha चल जाता है. So C alpha form होना चाहता हूँ. So it is going to be C of 1 minus alpha बचेगा. Equilibrium में C alpha होगा. Alpha is called degree of ionization. So here equilibrium establish करते हैं ना, it is irreversible. And यहाँ पर equilibrium establish करने का कोशिश करता हूँ and it is reversible. You have two types of thing, and Ostwald dilution law के पहले I just want to say this is Arrhenius theory and AB is a weak electrolyte. This AB could be a weak acid or a weak base. So I would say here मान के चलो आपको weak acid CH3 COOH, it is going to ionize to give rise CH3 and COO minus and Hu plus. Okay, now let us apply this same equilibrium constant, that is called as a Ka. is equal to CH3 COO minus and H plus and CH3 COOH. Why this is A? This is the equilibrium constant for a weak acid, that is called as acid dissociation constant. Okay, and अगर ये वाला base होगा तो क्या होगा? It is going to be ammonium hydroxide is going to ionize to gives rise ammonium plus and OH minus. ठीक है? And you have base dissociation constant Kb. Because it is a weak base, it is said that NH4 plus and the OH minus, and बच्चों you can see here clearly ये क्या बोलना चाहता हूँ आपके लिए. Now you can see for a weak acid and weak base, clearly you can see अगर ये वाला अगर H plus का वैल्यू बढ़ते जाएगा तो K वैल्यू भी बढ़ते जाएगा. So that अगर K वैल्यू बढ़ते ना एसिडिक स्ट्रेंथ भी बढ़ना है. Are you getting or not? Clear? And you can see here if Kb वैल्यू बढ़ते हैं ना OH minus भी बढ़ते हैं. Are you getting or not? Clear? And I want to say as Kb value increases and the basic strength increases. So this is the simplest ways where in my classes, dear children, on the YouTube platform, you may feel that on the YouTube platform kya chalta hai. If you are attending the classes on the YouTube platform, do we get a result? Yes, YouTube platform हमारा NEET Infinity Learn YouTube channel में सिर्फ सब्जेक्ट ही चलता है. So many students are subscribed to this channel and they are learning very good amount of the subject from us. Believe it, it is true, and you will be getting a comfortable medical seat. Not only medical seat, you will be a topper in the NEET as well. So follow us lectures and please subscribe to Infinity Learn NEET YouTube channel so that you are going to get all updates from the all sessions. And so far we are completed NCERT line by line, and we completed NCERT 1000 most expected question series, and we are in NEET one shot revision program. मान के चलो आप आज ionic equilibrium खुद पढ़ाई करना चाहता हूँ, you take a day or 2 days, but 2 hours I am going to complete in one shot. So it gives you a lot of impact, my dear students. Please use this chat box generously and talk to us, and you can ask any type of doubt by using the chat box, and definitely you are going to get a seamless preparation for your NEET examination. Ready for that? And also please watch the recordings, and if you have still doubts, use the comment box there, leave a comment there as a doubt, and we are going to reciprocate that doubt as well. Yes, it is. Okay, so stick to the principles and stick to the oath, crack your NEET examination. Okay, please subscribe the Infinity Learn NEET YouTube channel. Now in this case, I would say as Ka value increases, acidic strength increases. As Kb value increases, basic strength increases. Okay, now let us go into the Ostwald dilution law. So this is all about Ostwald dilution law. What Ostwald dilution law says? According to Ostwald dilution law, degree of dissociation alpha of a weak electrolyte is inversely proportional to the square root of molar concentrations. So the same thing I just want to say here, CH3 COOH ionizes to gives rise CH3 and COO minus and H plus. Initially, Sunil, so the effect of temperature on pH, stay tuned. I am going to tell you it's an awesome topic, and I'll give you the trick also. Stay tuned. Next 10 minutes I am going to discuss. आगे बढ़ते हैं, आपका pH scale भी मिलेगा. Sunil Dalvi, Now let us say initially C moles per liter taken, 0 moles and 0 moles are formed. जब equilibrium आता है ना, C minus C alpha consume कर चुका ताकि इसका C alpha बना हो पाएगा, है ना बेटा? And let us say it is a electrolyte, weak electrolyte, Ka is equal to, as you know, C alpha dot C alpha, C minus C alpha. Okay, I can write it is as a C square alpha square of C of 1 minus alpha, right? So C and square cancel करके आपका Ka is equal to C alpha square by 1 minus alpha, ताकि ये acid dissociation constant मान लो and base dissociation constant में. So for a weak electrolyte, alpha is less than 1. So it's very small. So ताकि इसका डिनोमिनेटर में ये वैल्यू इग्नोर कर सकते हैं, है ना बेटा? Yes. So that it is going to be Ka is equal to C alpha square. Alpha is equal to root Ka by C. That's what it is mentioned. So alpha is inversely proportional to root concentration. जब concentration कम होगा ना, alpha बढ़ते जाते हैं. Okay, alpha बढ़ने का concentration का है. Okay, and dilution बढ़ना है. When you add water, it is going to be diluted, so ताकि इसका concentration कम ही हो जाएगा. So that it is according to, this is Ostwald dilution law. This is called Ostwald dilution law. Are you getting or not? Any doubt, my dear children? Now, let's talk about the degree of ionization or degree of dissociation. We know it is the fraction of a total number of molecules which ionize or dissociate into its constituent ions. And alpha is the ratio of number of molecules that are ionized to the total number of molecules that are taken. So the values of the degree of dissociation depends upon the following factors. The first one is the nature of a solute. Strong alpha is nearly equal to 1. Weak alpha is always, for a strong electrolyte, alpha is nearly equal to 1, or a weak electrolyte, alpha is always less than 1. Nature of solvent, polar solvent ionization ज़्यादा बढ़ता है and non-polar solvent ionization ज़्यादा नहीं होगा. Sanil concentration, alpha is increases as concentration decreases, Ostwald dilution law का हिसाब से. And temperature, अगर temperature बढ़ता है ना, alpha value भी बढ़ता. Understand? These are the various factors that uses degree of ionization. So polarity of solvent increases. Polarity का मतलब इसका dipole moment ज़्यादा है, alpha भी ज़्यादा होगा. Understand? Clear? Next, Ostwald dilution law, we discussed this. Yeah, we already completed this. And concept letter. Smaller the value of Ka and Kb, weaker will be the electrolyte. Okay, so I just want to say acidic strength of a weak acid is directly proportional to its acid dissociation constant. I have given you acid dissociation constant of A, B, C. So the strength of the acid can be directly given based on this. Hi, Ashad Qureshi, good afternoon. And similarly, in the basic strength, Hope you enjoyed yesterday's class, Qureshi. So basic strength is directly proportional to the Kp value. Understand? And it is a concept clarity, and it is a very, very, very important. You can do the best based on this. And I want to say common ion effect, the value of degree of dissociation will be decreased for a weak electrolyte on addition of strong electrolyte containing the same common ion. So if just to say ammonium hydroxide is there, if we add something like ammonium chloride to that, which is actually a strong electrolyte. So because of this Le Chatelier principle, this equilibrium always try to come in this forward direction. This is what is called as common ion effect. Thank you. Thank you, Kurashi. Thank you. It was late, so I saw the recorded lecture. That was good. Perfect. And Sanil Dalvi, wait, I'm coming to your point, and please make an interaction. Okay, now here is the value of ammonium hydroxide is a weak electrolyte. Iska ionization suppress kar rahe hai. That is called common ion effect, and this is very, very important. And let us say acetic acid is a weak electrolyte. Acetic acid is a weak electrolyte. Iska ionization aise hoga. But when you add a strong electrolyte, iska acetate ion कॉमन मिलेगा दोनों को. सो ली शैटलेट प्रिंसिपल का हिसाब से ये आयनाइजेशन ऑफ एसिटिक एसिड वापस आने की कोशिश करता है. ओके, सो दिस इज व्हाट इज कॉल्ड एज अ कॉमन आयन इफेक्ट, and common ion effect is very much important and useful in the buffering action, okay, salt hydrolysis, pH calculations. okay, मैं एक ट्रिक देना चाहता हूँ आपके लिए. ये कॉमन आयन इफेक्ट का ट्रिक कहाँ इस्तेमाल कर सकते हैं, और बहुत आसानी काम है बेटा. ये क्या चीज़ है? इन प्रेजेंस ऑफ ये स्ट्रॉन्ग इलेक्ट्रोलाइट, ionization of a weak electrolyte is suppressed, therefore it can be ignored. That's it. So whatever the ions that are given by the strong electrolyte, you consider it. The ions furnished by the weak electrolyte can be ignored. ऑलरेडी ऑर्गेनिक केमिस्ट्री का 11th स्टैंडर्ड जो है, इसका ऑर्गेनिक केमिस्ट्री खत्म है. हाँ, परसों एरिन से बेंजीन का रिएक्शंस देना चाहता हूँ अर्षित कुरैशी. बाद में आपका आएगा केमिकल काइनेटिक्स, बाद में इलेक्ट्रोकेमिस्ट्री, बाद में अल्काइल हैलाइड्स, अल्कोहल्स, फिनॉल्स, ईथर्स एंड आल्डिहाइड्स एंड कीटोन्स. ऑर्गेनिक केमिस्ट्री आधा बचा है. मेजॉरिटी ऑफ द थिंग्स मैं खुद आपको पढ़ना चाहता हूँ. ओके, टेक केयर, वी विल डिस्कस दिस एज बेस्ट आउट ऑफ इट. ठीक है बेटा. डोरीमन, हर्ष कुमार, right, Arshad and Sanil Dalvi, and let's talk about concept later. Degree of dissociation of a weak electrolyte gets suppressed by the addition of a strong electrolyte containing the same ion. That is always best, है ना? That is always best. And also you can see now ionic product of water. Before going for this ionic product of water, I want to talk about pH scale आता है, and I want to give you a simple scenario about acid base theories. Okay, so acid base theories. This is about acid base theories. How many acid base theories are there? N factor in short in this only please. N factor redox में आ जाएगा बेटा अर्शद. We discuss this N factor in the redox, है ना? Stay tuned. So acid base theories, you have 3 acid base theories बच्चों. What are they? You tell me, what are they? Yeah, there are 3. One is Arrhenius theory. The other one is Bronsted-Lowry theory. And this is Lewis theory. Lewis theory. ठीक है, उसमें क्या क्या चीज चलना है? Take care. I am going to give you, everybody knows it, but I want to talk about a very important edges in this. So let's see on the Arrhenius theory. H plus donor is an acid. Donor is an acid. And OH minus and donor is a base. बस इतना ही. ओके, ये थ्योरी सिर्फ एक्वेस सॉल्यूशन के लिए भी इस्तेमाल कर सकते हैं. Solutions only, that's it. It explained which is a strong acid, which is a weak acid, which is a strong base, which is a weak base. But cannot explain the basic nature of ammonia, cannot explain the basic nature of metal oxides, cannot explain the acidic nature of non-metal oxides. Okay, bas itna hai. I don't want to discuss more. It discuss about the basicity. It discuss about the basicity and the acidity, and here talking about the N factor. If I talk about the N factor, you have to discuss about the redox reaction, structure of phosphoric acid, and get ready, and Arshad Qureshi, I will explain you in the P block elements for that, okay, or redox. Let me give you the actual criteria of the difference between these 3. Okay, it's over. Let's talk about the Bronsted and Lowry. Organic chemistry में ज़्यादा काम चलेगा है उसका. So what is this? Acid बोलते हैं इसका H plus donor. H plus का मतलब क्या? Proton. It is called proton. Okay, this is called H plus donor. And the base is H plus acceptor. I mean to say proton acceptor bus. Now it is applicable for all solvents, not only aqueous. All solvents it is applicable. It is applicable for all solvents. Okay. Yes, of course. ऐसा थोड़ा सा आगे बढ़ना है. Ashad Qureshi. Now here, if you talk about HCl, how do you say it is an HCl is an acid? Because there is an acceptor, so that a proton देने वाला है, so it is an acid one, and a proton लेने वाले है, it is a base one. It is going to give you Cl minus plus H plus H3O plus. It is called as base 2, okay, and it is going to be फिर भी acid 2. So I just want to say the conjugate acid base pair. ये दोनों जोड़ी है ना, this is called a conjugate acid base pair. Okay, a pair of species which differ in one H plus is called as a pair of conjugate acid base. Now, इसमें आपको क्या चलता है? A strong acid its weak conjugate base, vice versa. And if you understand this now, organic chemistry, total reactions you will understand. Okay? Total reaction you will understand. Arshad Qureshi. it could be NEET or any kind of JEE or any kind of examination. This is the key point. Therefore, the Brown-Stead-Lowry theory is very, very important for every student. Fine, my dear students. Talking about what is there in the Lewis theory. What is there in the Lewis theory? In this Lewis theory, you can say acid is the one you are going to see electron pair acceptor so one is an accepted, another one is a base, is a donor, and base electron pair donor. So the complete transfer of a pair of electrons from base to an acid and form a dative bond is called as a neutralization. So this is about the class of an acid, Lewis acid, the class of a Lewis base, and everything is going to be very important in classification. Any doubt, my dear children? If you have any doubt, you please ask us. Okay, so let's see. Ionic product constant of water. Ashad? Yes, ionic product constant of water. Liking this? Each and every point we'll be discussing in this is a product of the molar concentration of H plus and H3O plus or OH minus, it is denoted by Kw. You can write H2O as H plus and OH minus. So this process is called as autoprotolysis. So self-ionization of water. Is what is called autoprotolysis. Now when autoprotolysis happens, it is going to give you the products like this. You can say, let us apply. So K is equal to H plus and OH minus, H plus and OH minus and H2O. You can write K dot H2O molar concentration is equal to H plus and OH minus. Now what happened? This is what is called as concentration of the ionized water. When it is in a concentration of unionized water, इसका concentration हमेशा constant होता है. So constant multiplied with another constant is called as ionic product constant, is given as H plus and OH minus. Okay, so this is called as ionic product constant of water. इसका experimentally इसका value निकलेगा. This value is going to be 1.0 into 10 to the power of minus 14 mole square per liter square, and it is true in the case of 25 degrees centigrade. It is true in the case of 25 degrees centigrade. Understand? It's very, very important. Clear? Now let's see. Now This value is given as 1.0 into 10 power raised minus 14, and water being a neutral, so H plus concentration is equal to OH minus concentration, and here is a Kw is equal to Ka dot Kb. Take the negative logarithm, pKw is equal to negative log to the Kw. If Kw is equal to Ka dot Kb, so pKw is equal to pKa plus pKb. So if you take this value as 10 power minus 14, you are going to see pKw is going to be 14 25 degrees centigrade. With increase in the temperature, the value of Kw increases. For example, at 98 degrees centigrade, Kw is 10 raised minus 12. Fine. Now moving ahead, pH scale. Now Sunil Dalvi. So it was introduced by Sorensen for measurement of the acidity, relative acidity or the basicity of the given solution. It is a scale, pH scale, which measures the acidity and basicity. pH stands for potential the H plus or concentration of H plus are given by H plus is equal to 10 power minus px. pH is equal to negative logarithm to the base 10 of H plus ion concentration. So mathematically, Px is equal to negative logarithm to the base 10 of x value. So that if you want to say pH is equal to negative logarithm to the base 10 of H plus concentration. Okay. Similarly, POH is equal to negative logarithm to the base 10 of OH minus concentration. From here you can write this as H plus is going to be 10 raised minus pH. It is going to be OH minus is going to be 10 raised POH, and also pH plus POH is equal to 14. Mind it, pH plus POH is equal to 14. Fine. Now acidity and pH scale. You have acidic strength means the tendency of an acid to give H3O plus and H plus ions in the water. Yes, kitna de sakta? Arshad, Sanil, now. So the greater the tendency to give H plus, more will be the acidic strength of the substance. And basic strength means the tendency of a base to give OH minus ions in the water. Yes, of course, it is true. अब जितना बढ़िया तरीका H प्लस दे सकते हो उतना बड़ा एसिड है, स्ट्रॉन्गर एसिड बोल सकते हैं. Similarly, basic strength भी ऐसे देना है बच्चों. And so greater the tendency of OH minus ion is going to the stronger base, है ना? And the concentration of H plus ions in the written in the simplified form introduced by our friend Sorensen. Sir, is the part of organic chemistry because on GOC we study acidic and basic strength. Nah, acidic and basic strength are studied in chemistry, both organic chemistry and inorganic chemistry. Samjha beta? And you can see pH is given as negative logarithm to the base 10 of H plus ion activity, molar concentration of the H plus. So I have a statistic plan to calculate pH also. Stay tuned. Sunil Dalvi, that point is coming here. Let's talk about ASA activity of H plus ions in the concentration of free H plus ions or H3O plus ions in the solution. It is meant in the logarithmic scale. So the pH scale marks from 0 to 14 beta. 0 से कम ना आ सकते, 14 से बाहर ना जा सकते. So at a point is 7 at 25 degrees centigrade taking water as a solvent. So the pH scale आप जो इस्तेमाल करता है ना सिर्फ aqueous solution का इस्तेमाल करना पड़ता. And if the temperature, Sunil you can see if the temperature and solvent are changed, the pH range of the scale will also change. It is temperature dependent. So for example, 0 to 14 at 25 degrees centigrade, Kw 10 to the power minus 14, a neutral point is 7. For 0 to 13 at 80 degrees centigrade, Kw is going to be minus 13. Neutral point is going to be, pH is going to be 6.5. So अगर टेम्पर मान के चलो टेम्परेचर बढ़ते जाते pH कम आना है. Understand? Clear? Is very important. Now pH scale can negative or greater than 14, but pH scale cannot explain why so, it cannot be explained. Okay. So how NEET student understand logarithmetic is a part of maths? Of course, but NEET students are very good. I have a super awesome trick to calculate this pH scale. Okay, you need not have to worry about that. I am going to take care of. Stay tuned in the class. Everybody, I'll give you the simple trick. Okay, you don't claim that you are weak in mathematics, but I'm here for you to make you to understand, right? And you all see, my dear students, you are all various places from India. If the temperature change, the pKw will change and the pH will also change, of course. मान के चलो यहाँ पर देखो, look at this. Everybody, look at this. So he is been Arshad. No. It is, don't say sorry, Qureshi. Okay, anything you have that fail, you are asked. Sanil Dalvi, he is asking about this temperature change, and he is waiting since last 30 minutes to get the answer. So here Kw is equal to Hu plus and OH minus. Okay, इसका value है 10 power minus 14 at 25 degrees centigrade, right? Water being a neutral, so Hu plus is equal to OH minus. Okay, कितना होगा? So Kw is equal to Hu plus square is equal to 10 to the power of minus 14. Hu plus आता है आपका root over 10 power minus 14. Okay, so Hu plus is equal to 10 power minus 7. This is the scenario at 25 degrees centigrade. So that pH is equal to negative log to the base 10 of 10 power minus 7. So the pH आता है, water being a neutral is going to be 7. This is true at calculations, true at 25 degrees centigrade. It is for the weak and the strong. Let us say it is true, right? Now let us see, as temperature is increased, let the temperature is going to be, okay, let the temperature is going to be 90 degrees. So then Kw of the water is increased. As temperature increases, Kw increases, है ना? So इसके हिसाब से 10 power minus 14 से इंक्रीमेंट करके मान के चलो ये 10 power minus 12 होगा. मान के चलो ये 10 power minus 12 शायद होगा. 10 power minus 14 से 10 power minus 12 बड़ा नंबर है, कम नंबर है? जल्दी बोलो, बड़ा नंबर है, कम नंबर है? बड़ा नंबर है. सो ताकि इसका Hu प्लस कॉन्सेंट्रेशन कितना होगा, उसका रूट ओवर 10 पावर माइनस 12 होगा. इसका ऐसा है, राइट? सो इट इज गोइंग टू बी 10 पावर माइनस 6. अभी इसका pH वैल्यू है नेगेटिव लॉग 10 राइज माइनस 6 होगा. सो दैट pH वैल्यू है 6 होगा. जब टेम्परेचर 25 था ना, pH 7 था. अभी टेम्परेचर 90 डिग्रीज बढ़ गया ना, so pH कम हो चुका. So as temperature increases, pH decreases and vice versa. So Sanil, Arshad, Qureshi, you understand how it is impacting? Clear better? Arshad Qureshi. Yeah, that's good. Harshad, I'm calling you. So I'm very happy to hear your doubts. Don't say that, sorry, okay? Right, now let's say pH value and the nature of the solution. It's very important. For pH, H plus is greater than 10 power minus 7. The value of pH is less than 7. ताकि इसका solution acidic होगा. Okay, and for H plus is 10 power 7 minus 7, the value of pH is 7 and the solution is neutral. And for H plus less than 10 power minus 7, the value of pH is more than 7 and the solution is going to be basic. So in किस condition में acidic होगा, किस condition में basic होगा, you can all see the visualization. So जहाँ pH 7 है, neutral है, pure water, 7 का कम होगा, it is an acidic. You can see black coffee, tomato, apple juice, lemon juice, gastric juices. ताकि इसका 7 का ऊपर जाना है. Egg is alkaline, baking soda, hand soap, ammonia, bleach, concentrated alkalis comes under 13-14 का आसपास में है. Yes, of course it is from. अरे pH कभी भी होता है, कहीं भी हो सकता है ना. I just want to give you an exact relation here. The acidic and basic and the neutral, and this was the 10th standard and it is your 11th standard and your NEET and whatever the examination. So you can see pH is equal to 7. pH is equal to 7. Carefully you see pH is equal to 7. जब pH 7 होता है ना, it is going to be H plus का concentration मान लो 10 power 7 आता है. Okay, pH कम आ रहा है ना 7 का, H plus 10 power minus 6 का, 5 का 10 power minus 5 का, and 4 का 10 power minus 4 का, 10 का 10 power minus 10 का. Okay, now we can see the relative value of the H plus and OH minus ions. Yes, Anil, H plus is equal to, that is for weak acid, that is for weak acid, right? So as acidic nature बढ़ते जाता है, H plus concentration भी बढ़ते जाता है. Understand? Clear? Now we can see pH of a weak acid. Now, Sanil Dalvi, whenever you have a strong acid, you have to consider completely the H plus is equal to normality of a strong acid. But a weak acid, it is not ionizing completely, so that you have to consider Ostwald dilution law, and it is said to be pH is equal to C alpha or Cx. ताकि आता है इसका pH is equal negative logarithm to the base 10 of root over Ka dot C. मान लो ये formula. That's good. Direct formula I have given. Applied Ostwald dilution law. So you can say C of 1 minus alpha. Okay, X alpha मान लो, C alpha and C alpha आता है. H plus concentration is equal to C alpha beta. You should have a super command on these derivations. Okay, and it is going to be alpha is equal to root over Ka upon C, है ना? So ताकि इसका H plus ion concentration आता है C dot root Ka upon C. So H plus ion concentration is equal to root over Ka dot C. That's the reason why pH is equal to negative logarithm to the base 10 of root over Ka dot C. Okay, now we can say pH can be equal to negative log Ka dot C to the power 1 by 2. So 1 by 2 is the log. So pKa minus log C. Are you getting or not? Similarly for the weak base, the same you have to take the POH into the consideration ताकि आपको पता चलेगा pH is plus POH 14 का बराबर कर दो, pH and POH 14 का बराबर कर दो, so that we can say pH is equal to 14 minus POH. ठीक है, clear? That's good. Arshad, now my time I can't change. Mine is also time fixed, na? So mine is such a basis schedule. I can't change the time. Okay. From there you can say pH plus POH is equal to 14. Everything we have, right? On the plate. Such a beautiful presentations I made for you, my dear children. Here pH of a strong acid and strong base does not depend on the temperature. pH of weak acid decreases with increase in temperature due to increase in ionization. pH of weak base increase in temperature due to the increase in ionization of OH minus in concentration. And also you have various substances where the pH values are given. Sometimes you may have the weird questions. So gastric juice 1.0 to 3.0 आ सकते हैं. जब concentration of strong acid 10 power minus 8 mole per is the pH according to the formula. No. वो भी please wait for 10 more minutes. आपको पता चलेगा कैसे calculate करना है. हाँ, yes. Please stay with us. I am going to show you super awesome methods to calculate pH. Now, these are all the general way of soft drink: lemon, vinegar, urine, milk, saliva, blood, seawater, tears. Hurry, tears 7.4. Rona mat beta. Rona mat. Okay, seawater, don't taste it. Okay, blood. So it is not our food. Okay. Okay, saliva, it is there always in the mouth. Okay, and milk, it could be any milk. Okay, and vinegar and lemon, soft drink, gastric juice. Gastric juice, you have such an highly acidic thing, but we never have an experience because of this acidity. Sometimes the protective layer disrupt, you are going to get gastric ulcers. Okay? We're going to get gastric ulcers. Calculation of pH for different solutions. Okay, so Sanil Dalvi, calculation of pH of different solutions. You have a strong acid or strong base. Okay, now let's see here. So how to determine? For a strong acid, if concentration of H plus concentration is equal to normality of an acid, H plus concentration is equal to normality of an acid. Okay, if H plus concentration is greater than 10 power minus 6, then pH directly take negative logarithm to the base 10 of H plus ion concentration given by the acid, normality of the acid. That's it. Directly you can use it. If the concentration is less than this, if the concentration is H plus ion concentration is less than 10 power minus 6. Now what is the problem? You have to take Hu plus, consider ionization of water, ionization of water. So, when you take the ionization of water, Hu plus ion total is equal to Hu plus ion concentration given by the acid normality, plus Hu plus ion given by the water. So, I just want to say Hu plus ion concentration total is equal to Hu plus ion concentration given by the acid plus 10 power minus 7 लेना चाहता हूँ. So that pH is going to be negative logarithm to the base 10 of Hu plus ion concentration total. Sanil Danvi, fine. Any doubt? Any doubt? pH scale के लिए. Now आप बेस लेना चाहता हूँ, स्ट्रॉन्ग बेस. फॉर ए स्ट्रॉन्ग बेस फिर भी you can take, if OH minus ion concentration is equal to normality of base, normality of base. So if OH minus ion concentration is greater than 10 power minus 6, then POH is equal to negative log OH minus ion constant लेना पड़ता. ठीक है, क्लियर. ये आपका pH प्लस POH is equal to 4 के मान लो 14. So the pH is equal to 14 minus POH. बस अगर ये वाला pH plus ion OH minus ion concentration, if OH minus ion concentration आप ले लो is less than 10 power minus 6, then POH आपका जैसे टोटल लेना पड़ता, OH negative log OH minus ion total, and you can calculate from there. Are you getting or not? Clear beta? Sanil? Expected to ask any doubts in the chat, in the chat. Okay, now we are going to get into some more details about. Okay, let's see the further combinations of these acid base. So this is for the pure strong acid. My dear students, this is for the pure strong base. if strong acid mixers are there, if strong base mixers are there. Stay tuned. You want a short break? You want a short break? Or otherwise you want me to continue? Sanvi and Arshad Qureshi. Hurry, interact by using chart. Interact by using chart. Okay, let's talk about the mixture of strong acids. So you have two mixtures, okay, whose normality is 1, volume is 1, normality is 2, volume is 2. You got a mixture. So what is the pH of this mixture? So you have to take the H plus ion concentration of the mixture is equal to N1 V1 plus N2 V2 upon V1 plus V2. From there, pH is equal to negative logarithm to the base 10 of H plus ion mixture. Okay. Now, how do you do? For the bases, mixture of strong bases भी ऐसे ही करना और strong bases. Okay, for bases, OH minus ion mixture is equal to N1 V1 plus N2 V2 upon V1 plus V2. So ताकि इसका pOH निकालना, lot of patience is required to understand this, my dear children. And the pH is equal to 14 minus pOH. हो जाएगा ना? हो जाएगा ना? Yes. And students, I can guarantee you, after completion of my session, you are going to, अरे अबे आगे बढ़ना चाहता हूँ. After completion of my session, you don't leave any confusions. Okay. Now, a mixture का है ना? Yes. Sunil Dalvi want to say, strong acid and strong base का mixture रहा. Strong acid and strong base का mixture है. मान के चलो आपका Na is normality of acid and Nb is normality of base. ठीक है? And Va is equal to volume of an acid and Vb you say volume of base. Now your story comes. Your story comes after this story, a short break. है ना? Now here, if NaVa is equal to NbVb, ताकि a completely acid is going to kill the base, neutralization takes place, pH of the solution is going to be 7 because the reaction is completed, it is neutral. It is completely neutral. Okay. Now let us see if NaVa is equal to NbVb and if it is a reverse, क्या करना है? Okay. For that also I have a medicine and I'll give you the relevant formula and let us see the best. Mixture of strong acid and a strong base, my dear children. Here you can see if NaVa is greater than NbVb. So acid जीत गया. So that pH is going to be less than 7. है ना? Are you getting or not? so that H प्लस आयन निकालने के लिए आपका Na माइनस NbVb अपॉन Va प्लस Vb, ये H प्लस पकड़ के it is going to pH is equal to negative logarithm to the base 10 of H plus ion concentration. Are you getting or not? Okay. अगर यहाँ पर if Na Va लेस देन NbVb होगा तो बेस जीत गया. सो अगर बेस जीत गए तो सॉल्यूशन बेसिक होगा, pH ग्रेटर देन 7 मान लो. अंडरस्टैंड? सो ताकि इसका बेस का कॉन्सेंट्रेशन निकालने की कोशिश करो. NbVb से Na Va सब्ट्रैक्ट करना पड़ता अपॉन Va प्लस Vb. ओके, इसका pH कैलकुलेट सकते हैं पहले POH निकालने के बाद. नेगेटिव लॉग OH क्या हिसाब से करो बेटा, एंड pH इज इक्वल टू 14 माइनस pH करना है. ठीक है. अगर सॉल्यूशन ये वाला डाइल्यूट करने तो N1V1 इज इक्वल टू N2V2 भी हो सकता. दैट इज यूज डाइल्यूशन लॉ. समझ में रहे क्या? अभी थोड़ा सा शॉर्ट ब्रेक लेना चाहता हूं. स्टे ट्यून्ड फॉर 4 minutes exactly. I'll come back and talk about the buffers and salt hydrolysis, and everything will be in your hand. Okay, are you ready? Just 4 minutes break bachcho, because it's a long session. It is good we can have a small break. Fine, small break, right? Okay, stay tuned my dear students. Here it is for you, and I'll be back. Okay, coming. Thank you very much. Thank you. वापस है Sanil. Yeah, very good to see. So all enjoying the pH calculation tricks, and let us go into pH of weak acid and weak base भी देख चुका, and if it is pH of weak acid, pH of weak acid, H plus ion concentration is going to be, okay, root over Ka dot C, right? You can calculate the pH is equal to negative log root over Ka dot C, है ना? That's it. So let us go in a systematic way. Hope everybody can hear me. Hope everybody can hear me clearly. Please confirm, my dear students. Please confirm, my dear students. Now, pH of a weak base. Then we can say OH minus and concentration is equal to root over Kb dot C. From there, POH can be calculated negative log of root over Kb dot C. Kb dot C. That's it. Okay. Now, my question is, if you mix a strong acid and a strong base, and a weak acid and weak base, and weak acid with weak base. Got my point? So there we are going to see a lot more things. Mixture of weak acids. Let's see, mixture of weak acids. Weak acid 1 and weak acid 2. इसका मान के चलो Ka1 होगा, इसका Ka2 होगा, इसका C1 होगा, C2 होगा, है ना? Then H plus concentration is equal to, बच्चों it's very important, Ka1 C1 plus Ka2 C2, बस that's it. Got it? Similarly, mixture of weak bases. Mixture of weak bases. और कहाँ मिलेगा इतना elaborated explanation आपके लिए. So you have weak base 1 plus weak base 2. आपको जैसे OH minus ion concentration है is equal to root over Kb1C1 plus Kb2C2. इसका POH निकालना पहले, ओके, POH निकालना पहले, एंड pH भी निकाल सकते हैं. नेगेटिव लॉग OH माइनस कॉन्सेंट्रेशन करना, बस. एनी डाउट? Now let's talk about mixture of weak acid and strong base. Okay, so strong acid and a weak base. Okay, strong acid and a weak base. And let's say normality of an acid and volume of acid is greater than normality of a base and volume of a base. Now consider H plus ion concentration, okay, from the acid, strong acid. You have to consider it is going to be a strong acid, right? And you can calculate the pH out of it. Strong acid का हिसाब से. If normality of an acid, volume of an acid is less than normality of weak base and this is weak na. So this is going to form respective salt. So it is going to be salt plus weak acid bachega. That is the scenario. If that is the case, apply buffer concept. Apply buffer concept. If normality of an acid, volume of an acid is equal to normality of a base, volume of a base. If that is the case, only salt is going to be formed. When this is salt is formed, you are going to apply salt hydrolysis. Salt hydrolysis. In which case, which has to be used, everything is given in this. Similarly, you change this combination. You change this combination. Got it? Clear? Now, let's talk about the buffers and salt hydrolysis, solubility, equilibria, bacho, and limitations of pH scale. pH value of solution does not instantaneously give us an idea about relative strength of the solution. That is the one. Statement based question NEET एग्जामिनेशन में ये सीधा इस्तेमाल करो and इसका फ़ायदा उठाने की कोशिश करो. Please stay with us and like the sessions and subscribe to Infinity Lane channel. And pH is 0 for one normal solution of strong acid. ये 0 का मतलब क्या पता नहीं. pH is negative for some concentrated solutions, and how to interpret that. And at higher concentration, the place of pH, Helmholtz acidity functions are used, which we don't have right now. Helmholtz acidity functions, okay? That's a different matter. And talking about the buffer solution quickly, and buffer solution is the solution in which there is no change in pH takes place, even an addition of a small amount of an acid or a base. And it is also known as a reserve. It has a reserve acidity and a reserve alkalinity in it. So a buffer solution can resist the pH change on long standing or little addition of an acid or little base, or it can change a small temperature and a long storage also, because the buffer has its reserve acidity and reserve basicity. And some reactions takes place. During that reaction process, the pH also deciding factor to decide the rate of reaction. So before we start the reaction, we add a buffer to that. So what is kind of buffers we'll discuss here. So features buffer solution has a definite pH itself, and that is a definite reserve basicity and acidity, okay? And there is no change in the pH for long period of time. There is no change in the pH of dilution. There is a slight change in the pH, unnoticeable on addition of small quantity of either strong acid or a strong base. So Sanil Dalvi and other students, so please follow us here. Types of buffers. You have types of buffers, simple buffers and mixed buffers. Simple buffers is a mix, it is a salt solution of weak acid and weak base. But mixed buffer, you have acidic buffer and you have basic buffer, okay? So the pH of the acidic buffer, we can calculate acidic buffer, the solution of a weak acid and its salt with a strong base is termed as is acidic buffer, okay? Acidic buffer, for example, acetic acid and sodium acetate, talic acid and potassium thalate, boric acid and borax, and sodium bicarbonate. You have citric acid and sodium citrate. And in the NEET examination, I can guarantee you this better. And which of the following act as a buffer is a very famous question. And you have a basic buffer. Basic buffer, the solution of a weak base and its salt with a strong acid is termed as a basic buffer. For example, ammonium hydroxide and ammonium chloride, glycerin and glycerin hydrochloride. Okay, and ampholytes, a very good terminology, so I am just bringing you guys the compounds that contain both acidic and basic groups and therefore exist as Zwitter ions at certain pH, isoelectric point. And hence the amino acids and the proteins also act like a buffer solution because they are ampholytes. And another one is a mixture of normal salt and acidic salt or a polyvalent or a polybasic acid. Example, Na2HPO4, sodium, hydrogen phosphate and sodium phosphate. Sodium dihydrogen phosphate and sodium phosphate. These are all comes under this category. So where to use a basic buffer, where to use acidic buffer, does it depend on the nature of the reaction, not the nature of the solvent. Solvent is in the entire ionic equilibrium calculations, we take water as a solvent. There is no other way. Okay. Sanil Dalvi, you got your doubt clear? Okay, we'll discuss and Henderson-Hasselbalch equation and other stuff over here. अगर doubt है ना तो पूछना. And very famous question, which of the following act as a buffer? Which of the following act as a buffer? Which of the following is an acidic buffer? Which of the following is a basic buffer? Yeah. Now let's talk about buffer capacity. हर buffer का कुछ capacity होगा. That is called a buffer capacity. Buffer capacity is the ratio of number of moles of an acid or base added to 1 liter of the solution to change the pH by 1 unit is actually denoted by pi, and it is the number of acid or base moles are added upon change in the pH. This is called as buffer capacity. And also you have Henderson-Hasselbalch equation, and this Henderson-Hasselbalch equation is used to calculate the pH of a buffer. pH of a buffer is equal to pKa plus log conjugate base concentration by weak acid. So base by an acid concentration. Similarly, POH is equal to pKb plus log acid by base concentration. This can be used for the base. This Henderson-Hasselbalch equation is extensively used to calculate the desired pH of a buffer with the desired pH. Okay, I want a buffer. So buffer खुद का pH रहता है. So a buffer कौन सा pH में calculate करना, ये Henderson-Hasselbalch equation ज़्यादा मदद देता है. And talking about the salt hydrolysis, बच्चों, the salt hydrolysis. So when you say here acid plus base gives rise salt plus water, okay, and delta H is going to be negative. It is exothermic process. And salt hydrolysis is the reverse process of neutralization. So salt react with water and gives rise an acid plus base, and delta H is going to be positive, and it is thermodynamically endothermic reaction. In my sessions, you are going to get a super awesome points like this. Okay, so salt hydrolysis is an endothermic बच्चों, and therefore an increase in the temperature. You see, अगर आप मान लो temperature बढ़ते जाते, hydrolysis भी बढ़ते जाता है. Okay, that's very important, very important. You have salt hydrolysis is the ionic interaction between the ions of the salt and the water causes acidity or acidic solution and a basic solution when a salt is added to the water. Okay, so you can have the cationic hydrolysis एवं एनायनिक हाइड्रोलिसिस भी हो सकता है, एनायनिक हाइड्रोलिसिस भी हो सकता. So this salt contain a cation and an anion. So sometimes a cation can hydrolyze, sometimes anion can hydrolyze, sometimes both can hydrolyze. Who? Saurav Gupta. What is this? Okay. So when you see a salt is dissolved in the water, you are going to see a cation can be hydrolyzed or anion can be hydrolyzed. So it all depends upon who is going to provide you these counter ions. So the ion coming from a weak acid can be hydrolyzed. The ion coming from the weak base can be hydrolyzed. And the ion coming from either strong acid, strong base never hydrolyzes. Hope you understand this. Hope you understand this. And it is a reverse of neutralization. A solution of this salt of weak bases and strong acid, you can see. If a salt between a strong acid and a strong base, pH is going to be 7. A salt between a weak acid and a strong base, pH is going to be greater than 7. You are going to get anion get hydrolyzed. If the salt between a weak base and a strong acid, it is going to be acidic and pH is going to be less than 7, cationic hydrolysis takes place. And that's what it is mentioned. For a salt between a weak acid and a weak base is nearly 7, where you can see the pH is going to be nearly 7, depends upon the relative Ka and the Kb value. If Ka is greater than Kb and the pH is greater than 7, if Kb is greater than Ka, pH is going to be less than 7. Okay, shake. So recap this theories of acids. Of course, if at last, if time is left, I am going to recap it. You could ask what is an acid base theories before this, na? Okay, are you attending our classes right from beginning or middle you joined? Okay, anyways, now we discuss various types of different solutions here. You can see for a salt of weak acid and strong base like a KCN in the middle. Okay, no problem. If time is available, I can discuss shake with it. If not, please watch the recording. Okay. Saurav Gupta, please chart decorum charting में थोड़ा सा डिसेंसी भी होना चाहिए बेटा. आप किसने पूछ रहे हैं? हिंदी में बोल. एक टीचर का बोलने तो कुछ तरीका आता है ना बेटा. एक गलत बात है. सौरव, okay. For the salt of weak acid and strong base like KCN, so hydrolysis constant is equal to Kw by Ka. Kw is ionic product constant, Ka is acid dissociation constant. H is called degree of hydrolysis and is equal to root Kh by C, and degree of hydrolysis Kh का Kw by Ka होता है ना, so इसका Kw by Ka dot C होगा बेटा. एंड ऑन पीएच भी कैलकुलेट कर सकते हैं. इसका है ना K प्लस एंड Cn माइनस एनायन इज गेटिंग हाइड्रोलाइज्ड, ताकि पीएच इसका 7 का ऊपर होना. सो इतना कंफ्यूजन देख रहे हैं ना, डोंट गेट कंफ्यूज्ड. आई हैव ए सिंपल मेथड. ओके, pH of the salt of a weak acid and a weak base is independent of concentration. That is super important. I have a table. So if the solution is basic solution, example Na2CO3, Na2CO3 contain Na plus gives rise NaOH, CO3 gives rise H2CO3, so that it is a strong base, it is going to be dominated, so it is going to be a basic solution. So this is a simple trick. Saurav Gupta, okay, अगर आप Na2SO4 मान लो, okay, it is going to be giving NaOH, H2SO4, both strong. झगड़ा होने के बाद क्या फिर भी न्यूट्रलाइज होगा. The solution is going to be neutral. Okay, sir, actually I am from class 10th. Please give me a strategy for the chemistry. Definitely. So for that, Any student preparing for any competitive examination, any standard, chemistry can be prepared by taking the statistic point like stick to the fundamentals, stick to the fundamentals. Okay, how it is coming? How Na2CO3 gives sodium hydroxide, CO3 gives rise H2CO3. It is strong, everybody knows it, it is a weak. So you are going to get the behavior based on this. Okay, like that. Every point has its own strategy, my dear children. Okay, now let's talk about acidic solution. So ammonium nitrate gives rise ammonium hydroxide is a weak base, and HNO3 gives rise a strong acid. So it is going to be dominated. So the solution is going to be acidic. Understand? Clear? And this is the type of solution you can see. Hydrolysis at a glance. You have various types of salts. So you can see strong acid and strong base gas salt. Sodium chloride is an example. In carbonated compounds, how to deal with it? Stick to the chemical bonding. Shake with the if you are good at what do you say, chemical bonding and ionic bond, covalent bond, how the bonds are formed and everything, you will be good at that domain. Okay, coming to it is nature is neutral and degree of hydrolysis, no hydrolysis takes place, and pH is going to be, of course, it is 7. And for weak acid and a strong base, example acetic acid is taken, and it is nature of the solution is basic, and the pH can be calculated by this formula. And thank you. And if it is a strong acid and a weak base, the nature of the solution is acidic, and the pH of the solution is going to be pKb. pH is equal to pKw minus pKb minus log C by 2. You can say half pKw minus pKb and minus log C. And when you observe now, it is greater than 7, pH is greater than 7, pH is greater than 7. So pH is less than 7. So how to memorize this? pH greater than 7, na? You are going to say plus by 2. Less than 7, na? Acidic, na? Less than 7, na? You are going to say less than 7 here. So you have to subtract it, and it is nearly 7, na? You are going to be pKb plus pK minus pKb by 2. Very good, nice. So everybody take a snapshot. Everybody take a snapshot of this. Very good. Now solubility and solubility product, my dear students. In this solubility, it is noted by S, it is denoted by S, it is expressed in mole per liter or gram per liter. It is the weight of the solute in grams present in 100 milliliters of solution. And solubility is directly proportional to the concentration of common ions or the number of common ions. As common ion effect increases, solubility is going to be decreased. Important, it is very important. And you can say solubility increases due to the complex formation. Sometimes solubility, of course, increase in temperature as well. If you add ammonia to the AgCl, because of the formation of complex, it is going to be, AgCl is insoluble in water, but it is readily soluble in ammonia. Okay. And due to the formation of complex, Nessler's reagent HgCl is more soluble in potassium iodide. And we are connected this concept of solubility in concept of solubility in inorganic chemistry, even in the organic chemistry, that's very important. And also you can see in the analysis of second group cations like As2S3 or Sb2S3, SNS, they are given as precipitated as sulfides, so are soluble in ammonium sulfate due to the formation of complexes. हाँ, हिंदी में बोलने हैं, अभी पूछने का तरीका एक होता है ना. हाँ, राइट. नाउ सॉल्युबिलिटी प्रोडक्ट आता है. हाँ, सॉल्युबिलिटी प्रोडक्ट आता है जिस सॉल्यूशन में, सो मान लो ये AgCl है ना, it is soluble in A water gives rise Ag plus and Cl minus. आपका सॉल्यूशन ज़्यादा है, सॉल्ट है, रेडिली सॉल्युबल, जब पानी में डाल रहे हैं ना तुरंत सॉल्युबल होता है. Some are moderately soluble, some are sparingly soluble, they are soluble hardly. Okay, and such type of hardly soluble or sparingly soluble, so that equilibrium रहता है. So we have to apply the equilibrium principle. K is equal to Ag plus and Cl minus, and it is going to be AgCl. ठीक है बेटा. एंड अगर K एंड डॉट AgCl आना चाहता हूँ तो ये Ag प्लस होगा एंड Cl माइनस होगा. ओके, सो व्हाट इज दिस इज अ कांस्टेंट ना, ये भी कांस्टेंट होता है. कांस्टेंट मल्टीप्लाइड विथ और एक कांस्टेंट के वजह से दोनों मिलके इज गोइंग टू बी Kw इज गोइंग टू बी Ag प्लस एंड Cl माइनस आता है. सो इट इज नोन एज KSP, sorry, solubility में KSP, solubility product. In this you can say KSP. So the product of the ionic concentrations of sparingly soluble salt at saturated solution. This is only applicable for saturated solution. कौन सा saturated solution का मतलब कि जो solution है ना, ये जब इक्विलिब्रियम फॉर्म होता है ना, ये कंडीशन सैचुरेशन बोलना है. ओके, आर यू गेटिंग और नॉट? सो हियर इट इज इन ए सैचुरेटेड सॉल्यूशन, ताकि ये KSP वैलिड है. ओके, सो द प्रोडक्ट ऑफ द मोलर concentration of ions of an electrolyte at a particular temperature is known as solubility product. It is known as KSP. Okay, in that you can say at the saturated state the quantity of the solute dissolved is always constant for the given amount of a particular solvent at a definite temperature, and this is known as the solubility of the solute. And that can be given as a calcium fluoride reversibly gives rise calcium 2 plus and 2F minus. जब अनडिजॉल्व्ड सॉल्ट है, ये डिजॉल्व्ड स्टेट में है, ये दोनों का बीच में आपका इक्विलिब्रियम एस्टैब्लिश किया जाएगा. KSP आना चाहता हूँ कैल्शियम 2 प्लस का मोलार कॉन्सेंट्रेशन, फ्लोराइड आयन का मोलार कॉन्सेंट्रेशन, ये दो नंबर है ना, स्क्वायर में लगाना है इसका पावर. Ag2CrO4 सिल्वर क्रोमेट आइनेज करके 2Ag प्लस CrO4 2 माइनस बन गया. एंड KSP इज गोइंग टू बी Ag प्लस स्क्वायर एंड CrO4 minus 2. So it is called AB2 type. And you can see for a binary electron, मान के जाओ ये पर AB ये solid है. When you added the water, there is an unionized form of AB and ionized form of A plus B minus. ये दोनों का बीच में आपका इक्विलिब्रियम होगा. इसका आ सकता है KSP is equal to A plus and B minus जब तक टेम्परेचर आपका कांस्टेंट मान लो. एंड जनरल रिप्रेजेंटेशन इट इज AXBY, ये X moles of AY plus and Y moles of B X minus. So KSP is going to be the product of this AY plus. इसका concentration X से raise करना है, okay, and B minus X इसका concentration Y से raise करना है. So this is how you are going to see the solubility product, my dear children. Now let's see इसका relation between solubility and solubility product. KSP का S का relation आता है. Solubility product, let us say KSP is given here. Okay, I just want to write this as AB type na. Let me write this for you. So if I write, you will understand. Okay, it is given as A plus and B minus na. मान के चलो इसका S is the solubility. Okay, so KSP is equal to A plus and B minus. It is going to be S dot S. So I can say KSP is equal to S square. Solubility S is equal to root over KSP. ठीक है? So this can happen with AgCl, calcium sulfate or anything, AgI. ठीक है बेटा? Clear? Let us talk about AB2 type. Let's talk about AB2 type, salt of AB2. So AB2 gives us A2 plus and B minus. So इसका S 2S KSP is equal to S dot 2S square is going to be 4S cube. KSP is equal to 4S cube. S is equal to cube root. Yes, that's it. Now let's talk about A3B2 type. The same way it is coming to be 108 S to the power 5. Understand or not? It's a very informative. These slides are very informative. आपका आता है calcium phosphate is an example. Aluminum phosphate is an example. Okay. Now in general formula, AXBY is given as KSP is equal to AY plus to the power X, BX minus to the power Y, and it is going to be X to the power X, Y to the power Y, X to the power X plus Y is the best way to write this. Best way to write this, okay? And condition for the precipitation, this also we have seen. Yes, you can see, for example, copper chloride gives rise to Cu plus 2Cl minus. It is going to be 2S and 2S, it is going to be 4S cube. And no, 2 square, S2 plus 2 is going to be 16S to the power 4. Fine. Or an example, ferric hydroxide is going to be S3S. So 1 power 1, 3 power 3, S to the power 1 plus 3. It is going to be 27S to the power 4. Al2SO4 thrice, 2Al3 plus and 3SO4 2 minus 2S 3S, it is going to be 2 square 3 cube and S to the power 2 plus 3. It is going to be 108 to the power S power 5. Are you getting this better example? So many times these are the examples that has been asked in previous NEET medical entrance examination, and this kind of other examples you can expect it in the upcoming NEET examination. And ये वाला देखो काफ़ी important है, very 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 important है. इससे complicated वाला देखे आपको confuse करते जाता है. Now here you can see Na3, Li3, AlF6 twice. It is going to give rise 3 Na plus, 3 Li3 plus and 2 LF6 3 minus. Okay, it itself is a complex, so that it is going 3 square, it is going to be 3s, it is going to be 3s, it is going to be 2s. So 3 square, 2 square, s to the power 3 plus 3 plus 2. 2916 to the power s to the power 8. Understand? Clear? Like it? Very good. Dear children, these sessions that I am giving right now, it gives a lot of impact and a lot of insight for better scoring of your NEET examination. One shot we are discussing about One shot we are discussing about the total ionic equilibrium. Saurav Gupta, I think you can understand. आपको समझ में आ रही क्या बेटा? And Sheikh, and you have Sanil Delvi, Qureshi. That's good. Let's see. Solubility and criteria of precipitation. So every solution has its own KSP value at saturated condition. If KSP is solubility product, so it is taken for the solubility product for the saturated solutions. You talk about the KIP, ionic product, it is at any condition. It is at any condition. Only KSP is taken for the saturated solution and IP is taken for any solution. So here मान के चलो, if KSP is equal to ionic product, so the solution is said to be saturated and for the precipitation more solute to be added. If ionic product is greater than solubility product, which is actually constant, the solution is said to be supersaturated, therefore it is easily precipitated. Criteria of precipitation. If ionic product KSP is less than, ionic product is less than KSP, my dear children, the solution is still had to be a supersaturated, therefore no precipitation takes place. Here easily precipitated, it is said to be saturated. It is going to be super awesome concept. Criteria of precipitation. So this is the slide very important because in the NEET examination, KSP value will be given, ionic concentrations will be given, you are calculated to ionic product, then compare solubility product value and ionic product value, and you can decide yourself whether the precipitation takes place or not. The criteria of precipitation is indicated by super important slide. Everybody take a snap of this. Everybody take a snap of this. Okay, it's very important. Okay, now the solubility of calcium sulfate in water is 4.9 into 10 to the power of minus 3 mole per dm cube, means mole per liter at 298 Kelvin. इसके क्वेश्चंस कैसे निकाल सकते हैं बच्चों? So calculate the value of KSP for calcium sulfate. The solubility Ks S is given, solubility is given. You are asked to get KSP. Okay, ये कैलकुलेट करना बहुत आसानी काम है बेटा. The following equilibrium exists. Calcium sulfate gives us calcium 2 plus and sulfate minus. Okay, so KSP is going to be calcium 2 plus and sulfate 2 minus. Okay, you are asked to get KSP. Solubility is given, इसका yes and yes, S square होगा. So it is going to be 4.9 into 10 power minus 3. है क्या ना? Plug that value, square it. Okay, and you are going to be calcium 2 plus sulfate 4.9 into 10 power minus 3, 4.9 into 10 power minus 3, 8 is going to be 4.9 multiply करके 24 बन गया, and 10 power minus 3 is going to be 10 power minus 5. You are going to see 24 here. You see this mole per dm cube, mole square dm power minus 6. You see this unit. That unit can give you the insight of the actual value. And this is the solution. You can say simple S square. KSP is going to be S square. S is given. S is given directly. You can write it. Fine. One more titration. We are going to discuss about the titrometric analysis. A simple introduction about this. Titrometric analysis. अभी कभी किया क्या ऐसे? कभी किया? ऐसे experiment. So something is taken, this is what is called conical flask. Something is taken place in this burette, and this is the titration setup. When you open this now, the liquid which is dropping into the liquid that is already there in the conical flask, so that we can make it mixed. So we are making a liquid A to the liquid B. So I just want to say, in the conical flask you take analyte, is also called as titrant. It is known volume and unknown concentration. Whose concentration I don't know. For that we need a concentrated, some known concentrated solution. By doing experiment iska volume pata chalega. By applying the law of equivalence, we are going to use how much solution is used for this, how much solution, so that is called equivalent point. So that is called titration. So the titrant, the solution of known concentration which is added to another solution whose concentration has to be determined, and titrant and analyte, the solution whose concentration has to be determined. Okay. And equivalent point is very important, the point in titration at which the amount of titrant is equal to the amount of titrant, and completely neutralization or completion of the reaction taking place. And at the equivalent point of an acid base titrations, moles of an equal bases is equal to moles of an acid, right? And it contains salt and water. And if you say HCl is completely react with NaOH, and at the equal point sodium chloride and H2O is formed. So for that you have to add kind of an external substance to understand whether the reaction is completed or not. So for that, you see, an acid base reaction, when the neutralization is completed, there is a visualization in the change in the color, that is called end point. So end point देखने के लिए आपका जो indicator इस्तेमाल किया जाएगा. So this is synopsis of the various indicators that we come across with this. You can say phenolphthalein is used, which is actually colorless and acidic and pink in basic. So this is used 8.3 to 10.0 बीच में इस्तेमाल किया जाता है, and this is very important, and these values also you just keep in your mind. And methyl orange is another prominent one, which is red in acidic and basic it is yellow, and it is used in the pH range of 3.2 to 4.4, that's it. And you have bromothymol blue and phenol red can be used, which are yellow in acidic, while bromothymol blue is blue in basic, and the phenol red is red in basic. They are used nearby the same 6.0 to 7.6 and 6.8 to 8.0. And depending upon the pH of the end point, you have to select a particular pH indicator. Okay, that is a very, very important point. So we will be conducting a short session for titrations and all, as the time is being exhausted. My dear children, hope you love this session, and please like this session and share with your friends, and subscribe to Infinity Learn NEET YouTube channel, and stay tuned so that we will be providing this kind of sessions. Again, we are going to meet in day after tomorrow session, complete arenes we will be discussing. Again, I'll come back to the organic and I'll talk about the chemical kinetics and electrochemistry in one shot. Thank you very much. God bless you. See you for the day. Signing off, Suresh, Faculty of Chemistry. Please like and subscribe to Infinity Learn channel. Thank you.